All right, 5.2, graphing linear inequalities in two variables now. So in order to be able to graph linear inequalities, we have to be able to graph linear equations very efficiently. So let's just look back at a quick review on graphing. Identify the slope, y-intercept, x-intercept of each graph. Easiest way to identify slope and y-intercept is if we take it into y equals mx plus b form, where you've got your slope and you've got your y-intercept. So looking at this one, we've already got it into y equals mx plus b. So we can read right off of there. There's our slope. There's our y-intercept. So slope, m, is 2/3. Your y-intercept, b, is -5. X-intercept now. Whenever we want to find the x-intercept, we know that that point has 0 for the y. So x-intercept is always when y equals 0. Y-intercept is also always where x equals 0. And that's why when we have it in this form, that's why the last number is the y-intercept, because if you took x and put it in for 0, then you would get just the -5, which is your y-intercept. So to find your x-intercept, take it and place the 0 in the y. So it's the same thing as finding your zeros that we've already done this year. And then add the 5 over. That equals 2/3 x. And dividing by 2/3, same thing as multiplying by 3/2. So that's what we're going to do to both sides. Multiply by the 3/2 to cancel these ones out. And that leaves us with x is equal to 5 times 3 is 15/2. X-intercept 15/2. All right, let's find our x-intercept and y-intercept right off of these ones. When we have it in general form, find your x-intercept by making y equal to 0. So plug that in. 3x plus 2 times 0 plus 9 equals 0. 2 times 0 go to 0, so 3x plus 9 is equal to 0. And now we just start solving for the x. 3x is equal to -9. Divide the 3 over. X is equal to -3. There's your x-intercept. We're going to do the same thing for the y-intercept now. We're going to make x equal to 0. All right, so 3 times 0 plus 2y plus 9 equals 0. So 2y plus 9 equals 0. Subtract over the 9. 2y equals -9. Divide by 2. Y equals -9/2. We could have also found the y-intercept by taking it into slope y-intercept form. Y equals mx plus b. We're going to do that to find the slope anyways. So let's just work it through here. So 3x plus 2y plus 9 equals 0. Taking it into slope-intercept form, we're isolating the y. Get the y by itself. So we're going to subtract over the 3x and subtract over the 9. Which gives us 2y is equal to -3x minus 9. And now divide everything by the 2. Y equals -3/2x minus 9/2. Notice that minus 9/2, same answer we got here. So we didn't need to do that. I was just showing you how you could also do it in another way. Your slope now is right here. So slope equals negative 3 over 2. And we've got all the information. All right, we need to graph the line 4x plus 3y equals 24. Well, in order to graph it, easiest way is to take it into slope-intercept form and graph from there. Of course, you could graph with a table of values or finding x and y intercept and connect the two. Lots of different methods to graph that you learned in 10C. No, I'm going to take it into slope-intercept form. And we need to isolate the y. So then 3y is equal to negative 4x plus 24 divided by 3. Y is equal to negative 4 over 3x plus 8. Okay, so my y-intercept is at 8. Y-intercept is 8. And my slope is equal to negative 4 over 3. And that means 4 down and 3 right. So from that 8, I'm going to go 4 down, 1, 2, 3, 4 down, and 3 right. 1, 2, 3, point. And 4 down, 1, 2, 3, 4, and 3 right. 1, 2, 3. Connect those dots, extend it, and there's my line. Let's label that line 4x plus 3y equals 24. And now the question asks us, use test points to determine the region where 4x plus 3y is greater than 24 and where it's less than 24. So let's just take a test point. Pick any values. I like 0 and 0 is a good one. Let's take this point. We're going to call that A. So 0 and origin is always a really good point. If you have the opportunity to pick your points on these, pick 0 and 0 as one of them. The time when you wouldn't be picking 0, 0 is if 0, 0 was actually on the line. Then you wouldn't want to pick that one. Let's pick another point. Let's pick, I don't know, up over here. Let's call it, let's say, actually, let's pick one down here first. We'll go here, 2 and 2. Let's try that one. Let's pick something in the negatives. Let's call this one here negative 2 and negative 2 and I don't know, negative 2. Let's try that one. Let's take 5 and 3. A, B, C, D. Let's take one more. Let's take 4 and 7. Let's call that one E. Okay, so let's take point A. Let's plug it into the original, right here, and see if this is true or if it's false. Point A. 4 times 0 plus 3 times 0. Is that greater than 24? Let's see. 0 plus 0, 0 greater than 24? Not true. So it's not being satisfied by that. So that means this point is not meeting this criteria. It's not a place where this is true. Let's try B. And this one was for 0, 0. Point B, we said, was going to be 2, 2. Let's plug that one in and see if it is true. So 4 times 2 plus 3 times 2. Is that greater than 24? Let's find out. 4 times 2 is 8, plus 3 times 2 is 6. 14. That is not true. It's not greater than. So it's not going to be satisfying this inequality. Let's try point C. point C, we're choosing -2 and -2. Let's see if this one satisfies it. Finally, 4 times -2 plus 3 times -2. Is that going to be greater than 24? That gives me -8 plus a -6. Is that greater than 24? That gives me -14, which again is not greater than 24. So all three of those points did not satisfy this inequality. Let's try D and E and see what we got out of those ones. D. D we said was going to be 5, 3. Well, let's plug it in and see. So 4 times 5 plus 3 times 3, is that one greater than 24? We get 5 times 4, 20, plus 9, 29 is greater than 24. This one satisfies that. So we know that point D is in the region where we've got 4x plus 3y is greater than 24. Let's try point E. Point E was at, we chose 4, 7. All right. Let's plug that one in. 4 times 4 plus 3 times 7. Is it greater than 24? 16 plus 21. 37 is greater than 24. That one checks out as well. So this one is also in that area. So here and there, D and E that we chose was greater than 24. Huh. If I would choose any point in this area here, I would be greater than 24. So this whole yellow area will satisfy, any point in that yellow area will satisfy that first equation, or inequality. The second one now says, where is it less than 24? Well, all these other points were less than 24. This whole blue section is where the graph is less than. The line itself was equal. And right through, that line is the equal line. Above it is greater than, below it is the less than here. The graph of a line divides the coordinate plane into two different regions. The region above the line, the y-coordinate of every point is greater than the 2x plus 6 are. This region we say above is greater than. So when you're above the line, you're greater than. Notice this now. The graph is drawn as a broken line because we're not going to say it's equal to. The line itself is the equal to line. The inequality I have written here is just where is the graph, the y values, above the line. That's really what it's saying. Where is the graph? That's the y part. Above, that's the inequality, the greater than, the line. And the line is the 2x plus the 6. Notice that when we draw the line, and we label a line on your graph, which you have to label your line, it's always labeled as equal. We say that I was not including the line, I was not equal to the line, by showing a dotted line. But now if we look at this next one, we've got a solid line. because I've changed it from just greater than, this one's now less than, below the line, or equal to. So it's going to be a solid line. This one was, the first one was, where is the graph above the line, but not equal to the line. The second one is saying, where is, I shouldn't say the graph, where is, we shade above. Where is it below? Less than is below the line. Below the line. And equal to the line. And the equal to is a solid line. On Math Excel, if you go to the interactive, the online textbook there is a little applet, dynamic activity is what they call it, that you can actually move these things around. You can see and you can play with it and see where it shades above and below. So test points, just like we did in that opening activity, test points can be used to determine which region satisfies any inequality. Since all points above the line, y equals 2x plus 6, are solutions of the inequality y is greater than is always above the line, then the coordinates of any point in this region will satisfy the inequality. For example, if you choose -4, 3, you plug that point in and work it through, and you're going to see that the y value, the left side, is going to be greater than the right side. And that's going to happen for any point that's in this peachy colored area. Any point below the line will not satisfy it then. So if we pick a point below, 0, 0 is always a great point to pick. And if you plug that point in and work it through, it's not going to be true. The left side is not going to be greater than the right side. 0 is not greater than 6. So it does not satisfy. And because it does not satisfy, it's not part of the shaded in area. So a linear inequality with two variables, x's and y's, we can write it in its general form. It looks like these. But I always encourage you to take it into slope-intercept form. Y on one side. It's a lot easier to do all the work, and then you can just follow your little rule of greater than being above the line, less than being below. So always change it into y less than equal to greater than whatever. So isolate y. Isolate y before graphing. Make it a lot easier. All right. So first thing we want to do, we're going to isolate the y. We could use the intercepts to graph this. You could find your x-intercept. You could find your y-intercept. Plot those 2 points. Do the line. And then at that point, you would pick a test case. Picking 0, 0 as your test case is the best thing. It's the easiest one to use. Multiplying by 0 gives you 0. It's nice and easy to use. So I'm going to show you a couple different ways of doing these. This first one, I'm going to go through and take it into slope-intercept form. So to graph the line, that's step 1. Graph the line. So in order to graph the line is equal to. So we're going to change it into equal to. Okay, when we graph it. And actually, I'll change it to equal to after. Let's work it through here because we'll need this as well. Isolate your y. Start taking it over. So negative 3y greater than negative x plus 6. Take it over there. Divide by negative 3. Ooh, be careful though. When you divide by a negative in an inequality, you flip the sign. So we divide everything by negative 3. That gives us y less than now 1 over 3x. I change it in this form just because it's easier to read my slope off of it. I got negative x over negative 3. And then minus 2. Now I'm going to change it to y equals 1/3 x minus 2. That's what I'm going to graph. Let's graph this one. And then you have to decide, are you going to use a solid line or a dotted line to do this? Your y-intercept is negative 2. And your slope is 1 over 3. Up 1, right 3. Up 1, right 3. Up 1, right 3. Up 1, right 3. Or down 1, left 3. Down 1, left 3. Connect your dots. You've got your line. Oops. That's not looking so great. But there's your line. We label this, and we have to decide, is it a solid line or is it going to be a dotted line? Well, was the original question equal to? No. Because it was not equal to, the line's not going to be equal to, so we are going to do a dotted line. So it's going to look like that. A dotted line. And now we have to decide, where do I shade? Do I shade above or do I shade below? And this here is where you find out. Don't go to the original in this one. Go to when you have y isolated. Y is representing all of the y values. I want to shade. Y is my shading. The shading is less than, below the line. Shade below the line. The y is shade below the line. So we're just going to shade everything below the line. That's one method of being able to do these. But it requires you taking it to a y less than, in this case. If I didn't want to do it that method, I could have plotted my x-intercepts and plotted my y-intercepts, and then taken a test point. Again, the test point that I suggest always is your 0 and 0, unless that one's right on the line. But it's not on the line, so I'm going to pick 0 and 0, and then plug it into this original. Test point, 0 and 0. 0 minus 3 times 0, is that greater than 6? Is 0 greater than 6? No. If it's not true, this is shade. You don't shade that area, so you shade other side of line, since not true. So here's my 0 and 0. I need to shade on the other side of the line. So some people like to take it to this and follow that rule. Some people like to use the test point 0 and 0 and shade it that way. Either way is acceptable. Okay, so in order to graph this one, it does say graph with your graphing calculator. So I'm going to do that next. I'm actually going to graph manually first and then show you the calculator as well. But in order to graph in your calculator, we need to isolate our y. So we have to do it that way. All right, so negative 3y is greater than, let's start moving those over, negative 2x minus 11, divide by that negative 3. Ooh, swip it. And that gives us now negative 2 divided by the negative 3, which gives us 2/3 x plus 11/3. Oh, there's my y-intercept, 11/3. That one's not that great. And then a slope of 2/3 from there. We now have fractions to work with. This is, when you get this type of a question, it's a lot of times easier just to use the x and y intercept method to graph manually. So let's graph it manually with x and y intercepts. I know my y-intercept is 11/3. Just take that to a decimal because it's easier to throw down onto your graph. So that would be 3 2/3, so 3.67 approximately. My x-intercept, we're going to find that by plugging in a y of 0. 2x minus 3 times 0 plus 11 equals 0. And when we're finding the intercepts, we can just use the equal, because we're trying to find out what the x-intercept equals. 2x plus 11 equals 0. So 2x is equal to negative 11. Divide by the 2. X is equal to negative 11/2. Which gives us, as an approximate decimal, negative 5.5. So let's put those two on there. Negative 5.5 right there, and 3.67 right there. Okay, no, that would be negative. I need to move it to the positive one, 3.67. There, that looks a little bit better. Now we connect our dots and extend the line. And you have it graphed manually. In this one, we can't just go and look at this and say, all right, where is it above or below the line? I can't do that. I can only take that above and below the line where to shade when I have it isolated for the y. Isolating for the y says shade below, because it's less than, the graph. Shade below the graph is what it's telling me. I'm going to use my test point again just to make sure. Pick that test point at 0, 0. And let's see if this one is going to be true. So plug it into the original. 2 times 0 minus 3 times 0 plus 11. Is that greater than 0? 0, 0. So 11 is greater than 0. Yes. So this is true. So shade same side as your test point is in. My test point is on the below side, which already we knew. That's the side that we shade. So you shade this whole area in. That's graphing of an inequality. When you graph an inequality, you're graphing where is the shading. All of these points are true. Anything that's in the shaded region is true, satisfies this inequality. It's not just one specific graph. Now, last thing that we had to do, and I should have done it before, but that was, is this a solid or a dotted line? You go right back to here, and because it's not equal to, this is not supposed to be a solid line, I need to make it a dotted line. There we go. Label the line. The line is y equals 2/3 x plus 11/3. You can label it that way if you want, or you could label it as this, the original, with an equal sign. 2x minus 3y plus 11 equals 0. The line is always labeled as the equal. The shading is the inequality. Okay, so in order to do this now on a graphing calculator, you have to have it as a y isolated first. So y equals, because you're always graphing the equals, so I'm going to put in 2/3 x plus 11/3. That's going to graph the line, but I need to do the shading. So the way that you do the shading is I know I'm shading below. So you're going to go and front of the y equals, hit enter, gives you a thick line, hit enter again. Shades above the line, hit enter, shades below the line. So I know I want to shade below the line, so now I graph that. And it's going to graph the line with a shading. It doesn't do the dotted. You have to do the dotting thinking yourself. All right, so now a realistic problem. These types of problems here are more realistic than the systems of equations that you did last year, where things are equal. You have $15 to buy seeds. You don't have to use all the $15. You have up to $15. Makes it an inequality. There are more inequalities in real life than there are equations. A package of vegetable seeds is $1.50. Package of flower seeds, $2. Write an inequality now. So I know my two variables are vegetables. So we're going to say V equals veggie seeds. And we're going to say F is going to equal flower seeds. So $1.50 for a veggie seed plus $2 for a flower seed has to be less than. So whatever I choose to buy has to be less than or it can equal $15. Okay, so then in order to graph this, okay, so that we can see how we can answer the rest of the questions. In order to graph this, I could either take it, choose which one is x and y, doesn't really matter, or we can use the intercepts. I'm just going to use my intercepts. When v equals 0, if I buy no veggies, so when v equals 0, I can just plug in that, work it through. F's going to equal 7.5. Just working through. If f equals 0, then our v is going to equal 10. And because it doesn't matter which one's x and y, I'm just going to say that the first one's x and the second one's y. So then let's plot it on here. X, v, and f. And I only actually need quadrant 1 for this one. So I'm going to change my graph here. All right. So now I've just got a quadrant 1 graph. I don't need all 4 quadrants because we can't have negative number of packages of seeds to buy. And then we just plot those 2 points, a v of 0 and an f of 7.5. And then an f of 0 and a v of 10. And right there. Determine 2 possible ways Carmen can spend up to $15. So we're going to look for, really what they're asking you for is what test points would work. Well, let's see. Where would we be looking? If we're saying that we can only spend up to the money, then it's going to be below the line here. Because this is going to be more than what we have. So we're looking for things in here. Let's just pick one. How about 6,2. There's a point right there. You can go ahead and buy 6 veggie seeds and two flower seeds. That point is underneath here in this area. Anything in that area we can buy, including this line as well. What's another option? How about 2, 4? Hey, that one would work as well. 2 veggie seeds, 4 flower seeds. We got enough money for that as well. So we'll call this one point A. Oops. And we'll call that one point B for the 2 ways that we can do it. Now, can Carmen buy 5 packages of vegetable seeds and 4 packages of flowers? That would mean point C, which would be 5, 4. Let's find out. 5, 4. This point right here is above the line, just above the line. No, we can't. We could algebraically plug them in. We could plug in 5 for V and 4 for F and work it through and see algebraically if it's less than or equal to $15. Or we can do it graphically and see that it's above the line, so no, she can't. No. This point is above the line. Or if you did algebraic, you would say does not satisfy the inequality. What is the most money Carmen can spend and still have change from $15? Well, we need to go to the graph. That's a lot easier. Otherwise, we're doing guess and check all the way through of all possibilities. We're looking for what points are closest to the line in the yellow region. Or right on the line would even be better. And you can see I'm not perfect on here. Yours should be better if you did it on graph paper with a straight edge. Mine's not straight. You can see I even missed the line a bit there. But what they're suggesting is 7 and 2, which is going to be just below the line. So they're saying here in the answer key that we've got 0.7, 2, which would mean 7 vegetable seeds and 2 flower seeds. Working that out together, 7 times $1.50, 2 times $2 gives you $14.50. We need to find points on there that are going to be on the intersection here of the grid because it has to be whole numbers. We can't have part of a package. Answer up the 2 quick discuss the ideas questions just to bring together what you should have learned from this lesson here.